All right, hi guys. This is Miss Bufford, and this presentation is on building block 3 of Unit 12 on solutions. And in this presentation, building block 3 covers electrolytes and non-electrolytes. So basically, we're just going to learn what an electrolyte is and what an electrolyte is not. And then we're going to talk a little bit more about them, but this presentation should be pretty short. All right, so your learning goals are to be able to explain and give examples of electrolytes and non-electrolytes. So first things first is electrolytes. You've likely heard the word electrolyte before, usually in reference to sports drinks that you might drink after a workout or playing like a sports activity, or maybe just working outside and sweating a lot. Because when you sweat, your body loses a lot of the salts that it needs to function, and it's really important to keep those replenished so your body can perform a lot of the functions that it needs to perform. So electrolytic solutions are solutions that contain electrolytes, and an electrolyte is a substance that dissociates into cations or positively charged and anions, negatively charged ions in solution. And when it does this, these solutions that contain positive and negatively charged ions gain the ability to conduct electricity. I know in class we've talked about before that pure water cannot conduct electricity by itself. It has to have some dissolved ions in it, some charged particles in order to be able to do that. And an electrolyte is something that dissociates and allows water to conduct electricity. Some examples of these are just any ionic substance that dissolves in water. Bases are considered ionic substances. I know we have not covered the acid-base unit yet, but I am going to mention them here because we're going to talk about them again next unit when we get to the acid-base unit. So salts and bases are considered ionic substances that will dissolve in water or dissociate in water to form those positive and negatively charged ions. And then I'm also going to include acids as electrolytes. And acids, I'm talking about those separately because they're considered covalent substances because they're made of nonmetals, but they have what's called acidic hydrogens in their formulas. And these acidic hydrogens, the reason we call them acidic is because when we put an acid into water, these hydrogens will dissociate and form positively charged hydrogen ions and then anions depending on what kind of acid it was. So acids are also electrolytes because they will dissociate into positive and negatively charged ions in solution. So over here, I don't think my cursor is being recorded for this presentation, but if you take a look over at the pictures, the first one up near the top, you can see how this potassium chloride salt is being dissolved by these water molecules. We've talked about dissociation in previous videos. And then you notice just table salt is an example of an ionic salt that will form an electrolytic solution. And then Gatorade is a sports drink. It's an example of a way that you can replenish the ions, that get depleted in your body when you participate in sports or other activities that cause you to sweat a lot, because when you sweat, you lose electrolytes. All right, and non-electrolytes are any substance that does not readily dissociate into cations and anions in aqueous solution. This includes polar covalent substances that can dissolve in ionic solution, but they don't dissociate. And so remember we talked about the fact that sugar can dissolve and because it's polar, but the sugar molecules themselves are not actually being broken apart into positive and negative parts. Water molecules are just surrounding a single sugar molecule and moving it away from the rest of the sugar. So there's no charged particles in sugar water. It's just sugar molecules spread out, surrounded by a bunch of polar water molecules. They are also nonpolar substances that are not soluble in water, and a nonpolar substance that's not soluble in water would be like butter or olive oil or any kind of oil, because we know that oil and water, they don't mix easily. Or they could be ionic substances that are not soluble in water. So there are some ionic salts whose attraction between the positive and negative is so strong that, water can't get in between them and pull them apart. And so that's anything that is ionic that is not soluble in water is not an electrolyte. It has to dissociate in order to be considered an electrolyte in water. And we'll talk more about insoluble salts in building blocks coming up, how to identify those. So some examples, we have rubbing alcohol, which is a polar covalent substance. It will dissolve in water, but it will not conduct electricity because it does not dissociate. And the same for sugar, that's a polar covalent substance. And then oil and butter and anything greasy like that would be a non-polar substance and will not dissociate or dissolve or mix into water. So none of these substances, when mixed or when trying to mix with water, will allow for the conduction of electricity because they don't form positive and negatively charged particles. If you take a look at the little picture up here at the top, you can see that this would be my example of an insoluble salt, because you can see that you've got all these. It looks like an ionic substance with how the atoms are kind of packed together in a pattern, but the water molecules are not able to dissolve those from the rest of the pack. So those are non-electrolytes. And now there are some differences between electrolytes. Not all electrolytes are created equal. Some electrolytes are considered very strong electrolytes, and others are considered pretty weak electrolytes. And there's a spectrum. It's not all of them are super strong and all of them are really weak. It's, there's some in-betweens. But to give you an example, if you take a look at these beakers up here at the top, again, I'm not sure if my cursor is being recorded. Try to get that in there. So you take a look at the beakers up at the top. The first one, you can see that all of those particles are dissociated from one another. None of them are still stuck together. And that would be considered a strong electrolyte because all of them are dissociated. That's putting a lot of ions into that solution. And if you take a look at the beaker right below that, you can see by how well lit that light bulb is that this is conducting electricity very well. So that is a good indication you've got a really strong electrolyte. The intensity of this light is directly proportional to the amount of electricity that's being able to be conducted through this solution right here. If you look at the middle beaker up at the top, you'll notice that some of these have been dissociated and some have not. And so this would be considered a weak electrolyte because it's only putting some ions in solution and not all the particles are dissociating. And so if you take a look at the middle beaker down below that, you'll notice that the light bulb is still lit up, but it's not nearly as bright as that first one. And so this is still conducting electricity. So this is still considered an electrolyte, but it's a weak electrolyte. And then if you take a look at the last beaker up here at the top, you'll notice that nothing inside this beaker is dissociated. It's all dissolved because it's spread out evenly in that beaker, but nothing has been dissociated into positive and negative charges. And if you look at the beaker down below that, the light bulb is still not lit at all. And that means that there's no electricity flowing through that solution. There's no charged particles to allow the electricity to flow. And that just happens to be an example of ethanol. So we'll say that's all ethanol in there. And ethanol is a polar covalent substance. It will dissolve in water, but it will not conduct electricity. All right. And the last slide right here is your help at home video. So if you would like another explanation, you're welcome to watch the help at home video. It's found in the PowerPoint that's listed as a resource on this building block page. If you have questions, feel free to email me. Again, I know that I said this in a couple of lectures in the learning pathway before, but my new office hours are going to be Monday through Friday from 11 o'clock, I'm sorry, from 10 a.m. to 11 a.m. So if you want live help online, you're welcome to message me through It's Learning or through the discussion board that's posted on the homepage. Or you can send me an email and I'll get back to you within 24 hours.